Okay. Yes. All right. Hello, everybody, and welcome to my second seminar, disassembly. This is my own seminar this time, so I'm just talking from my own perspective about technology and sort of my experience with working with visuals throughout the years and how I've tackled some problems that have cropped up and how I sort of ended up on the browsers and doing stuff on WebGL. My history of programming is really started with me in primary school doing simple pixel stuff on QBasic with MS-DOS, and I worked my way up to Turbo Pascal and VGA programming later on, and even did some inline assembly stuff for 386 processors. Then I got sidetracked from using pixels and frame buffers and coded for the NES and Atari 2600 for a number of years, where I was mostly doing sprite-based or scanline-based or tile-based graphics. So totally different beast, totally different way of doing graphics. And after that, I got into OpenGL, started learning it at work and then off time at work, and got into, okay, maybe I should also learn about GPU acceleration and doing graphics on the modern display chips as well. And I think the most easiest way of showing what a pixel-based effect really is just to code it. And because I have the tools here and I can just speed code a little effect for you to show how something like a pixel effect actually works and how one can make it with the proper tools. I'm using a development tool called Processing, which runs on Java, does rendering on GDI and OpenGL and whatever, can be pretty easily added features with plugins and stuff like that. So it's sort of like a programmer's toolkit for doing visuals and input and sounds and data processing, whatever. You can run it on Windows, OS X, and Linux, and you just have to write it once here, and then you can just export your application to all those platforms with a native executable, so you don't really have to install anything for the end user when you do your software in processing. But the way I can do it here is very, very quick. Set the resolution, set the frame rate. That's all the setup I need. Then I have one single function that gets called every frame called draw. Set the background color to black. Then I do a quick loop for the Y direction or up and down. Go with the resolution here. I do another loop inside it for X or the vertical. Inside it, I define a single color, like this. And these are derived from that would be X times 0.001 plus the timer in milliseconds. This is probably something you've seen like quite many times if you watched old demos, at least. Then we just define one single color here and set the pixel to X and Y and this color. Oh. Ta-da! Pretty simple stuff, but yeah, it works. We can just change it very quickly if we want to. Do it like this, for example. Or like this. Oh. That didn't look too interesting. Some bars. Compute that with a sinus and timer, really. Nothing too fancy, but good example of showing what I can do with just setting a few pixels and coding it in a few seconds, really. It's a start. So basically, what I didn't really do here, because I didn't really access a frame buffer in the memory, which would be an array of pixel curl values or palette index values or bit plane toggles. For example, on the Amiga, you can't really set one pixel just by writing into memory, like, I want this color on this position on the screen. But you have to set it on different bit planes that say that, okay, these bit planes are basically blended together, and one single bit plane just has a single color you can set on and off, and if you set them on top of each other, you get different colors out of it. And sort of the basic definition of a pixel-based effect for me would be setting pixel colors according to position, time, function value, etc. The variables there can be just pretty much anything, and I always sort of thought that if I have a frame buffer, I can render the world. I can do anything with it. The speed is maybe an issue, but I can do anything with it because I'm controlling light, basically. And as I started doing this stuff quite a lot when I was younger, I was making small games and maybe a little demo-style little programs on different languages and platforms, and everything was always coded for one single production, and nothing was really reused at any point. I didn't have any tools. I just probably made some images in Deluxe Paint, but that was it. I didn't have any actual visual creation tools. And doing this for some years, I really got tired of always having to start from scratch and sort of thinking that, okay, whatever I'm doing, it's always going to be very bad quality and I can never reuse it or get anything out of it afterwards, or I can't give it to anyone else to use or to learn from. It's basically just meaningless technology behind something that I've done. And found myself toying with the idea of maybe if I just concentrated on doing a visual editor for demos and maybe had some sort of tool to actually help making them and address many of the issues I ran into when I was just hard coding my own programs. And the first tool I created was Spliff, or Trilobit Scriptable Lua Interactive Multiplatform, which was created to tackle a multitude of problems I had with software development on these current sort of desktop platforms. Because the first thing was that I always wanted to do whatever I was making to be multi-platform, so you could run it on OS X and Windows and Linux, and you didn't have to think about it. You just had to get the zip file with the demo, and you could run it on all those 3 platforms. You didn't have to do anything else. And Spliff is inherently multi-platform because all the code in it is made with Lua, except the actual stuff that calls the system functionalities, such as OpenGL and that stuff. But all the demo code itself is Lua, and all the GL calls to OpenGL are coded with Lua as well, which is a script language or a interpreted language. So you don't have to compile it. You just have to give the Lua interpreter the source file it has to run, and then it just starts happily grinding away with the Lua code. And having a script language also makes it possible that all the visual code I'm writing is reloadable without relaunching or recompiling the program. So I can just make my own sort of player executable, run it, and then I can just have an editor window open at the same time and change effect parameters and whatever, and then just press a single key and I can see the changes without having to restart my program or recompile or do any of those sort of meaningless tasks I really find annoying when I just want to, okay, I want to change the color of this circle now, and yeah, but I have to go through this number of windows and compile and go through compiler errors and all this stuff, so tiresome. And the demo player has seeking function, so I can just go in the song, rewind, and jump into whatever position in the soundtrack I'm using, and see the real-time output on that part of the song, and I could just go go through it, seeking and seeing, okay, this should go here, and maybe this should go here, and I can press number keys and set sync points when I'm doing that, so I can mark sort of a list of things I want to remember. Okay, at this part of the song, I probably want to start something happening, and make those sort of mental notes with that. And my sort of mantra making this was that the demo is the editor, so I didn't really achieve that, but that was sort of the goal anyway, that I would never have to sort of close the demo at all, and it could just develop the visuals while I'm sort of running it. And because I'm using Lua and I'm not crypting it or packing it or anything, everything is open source. So all the demos I made with this come with the full source code of the demo as well, and can be just opened and read and changed and do whatever with it. And with Spliff, I can sync visuals to the sound in multiple ways. I have a timeline file for millisecond syncing of demo parts, which is basically a file telling time offsets to the song and what to render at that point. And then I also have FFT-based beat sync for effects, so I can detect whether I'm getting some nice bass sounds out of the soundtrack or whatever. I can do all sorts of frequency analysis with it and use that to control color, position, effect, parameters, whatever. And seeking for testing. But also this way of doing them has had a lot of flaws in the end, even though I was very optimistic about it at first, because for one, I was fixed to OpenGL 1.1, so I couldn't use any shaders, and upgrading would have required recompiling the libraries I found on the internet and going through them and seeing what's really the best sort of library for OpenGL bindings on Lua and that sort of stuff, and I never really got around it to actually fix it and make it support OpenGL 2 as well. So no shaders. Had some terrible hacks for texture handling, like had some problems basically the way Lua handles memory and does some things pretty strangely. I never really understood why some things seem to work properly and sometimes they just didn't. No clue there. Probably just my own incompetence in coding, as it usually is. And the OpenGL version I was using was found to be incomplete as well, so there was a number of OpenGL functionality missing there. But I sort of lived with it. Did a few demos on it anyway. Didn't really bother thinking about those flaws too much when I was making stuff with it. And I did one demo for last year's assembly with it, and I'm now going to run it for you. Saisiko ääntä? And the most interesting part here is that, yeah, as you probably saw in the first frame, the demo actually still contains all the sort of syncing functions I built into it, even though I'm just downloaded this from Poet like few minutes ago, and I didn't really have to do anything else but to enable the debug mode in the source, so I can just toggle this with space and go through it. I can seek with keys here, and I can even pause it and go very, very slowly, 10 milliseconds at a time, and really look at each frame and see how it works. Go through the visuals like that. As you can see, some of the effects are not based on time, have other means of making them run. So this is not actually frame perfect in the way. The music has to be running for it to be perfect. And I can set the sync points with a key here. And I get a list of them when I quit. So that's it. Pretty simple. Like, I just didn't see the need of doing anything more fancy than that. That solved all my needs at that point, what I wanted to do with my tools, and I just hard-coded everything else. Then I heard about WebGL, and I was sort of already bored at this project and knew that I wouldn't have the sort of motivation to fix this, but I'd rather do something from scratch anyway and start making something new. So I heard about WebGL, and I got the idea of doing something like Spliff, but in the browser, would have that sort of same sort of easily reloadable and tweakable visual stuff built into it as well. And because WebGL has shaders, the natural choice there was to enable the editing of shader parameters and JavaScript variables real time. And because I just wanted to do keyframe and time-based animation there as well, so I was already thinking that, okay, probably have to have some sort of advanced interpolation of different values for parameters and stuff like that, so that went into it as well. And the technology behind this engine I'm calling DarumaGL is that it's basically one single WebGL canvas for the output. That's the size of the browser screen. Works with any resolution, any sort of aspect ratio. Doesn't matter at all. It's made with pure JavaScript, HTML5 and CSS3 for the UI. So WebGL is all, of course, JavaScript code calling WebGL functionality, renders to canvas, and the editing part is made with HTML and CSS, so no plugins necessary at all. Textures are loaded from PNG files on the server, from JavaScript during page loading, and audio is done with HTML5 audio with OGG files because MP3 files only work in Chrome, and Firefox doesn't support MP3 at all, so I'm just going with OGG because it works everywhere. And timeline.js is the component I used for the keyframe editor because I found this very simple looking and versatile keyframe editor module for JavaScript that renders, in a happy accident, renders the same way the keyframes that Adobe Premiere does. And if you're not familiar with it, it's the video editing program, and all the effect keyframes are edited in the same sort of layout and UI there as well. So I found that to be the most familiar for me anyway, and the way I really learned video production anyway was on Premiere, so I decided to use that and plug it into my sort of simple WebGL engine. And now I'll give you a quick demonstration of how it works. Straight from the internet. No connection, eh? Okay, we'll use the cable. De-dum. Maybe I'll just try this. Yeah, there we go. I have the sound on mute for now, so you can just concentrate on how I do actual editing here. Okay, it's running there, though. Okay, so basically here I have the timeline component, and here I have the WebGL view in canvas behind it, and I have exported a low number of WebGL parameters and shaders and JavaScript variables here, which you can see, for example, this controls the tunnel, and this controls the flower effect and the plasma effect, and I've just exposed a number of parameters from the demo here. So if I want to change something, for example, the green tunnel here, I could just go here and click on these keyframes, and I get a nice editor box, and I can just type anything I want here. 0. Yeah, there we go. Don't move so quickly. Or I can set it to 4 and just watch what it looks like now. Okay, not very good. It's going large. And I can set the interpolation of the keyframe value here based on a number of curves and even some effects like bounce here and backing, and I can set the easing as well for the curve and play around with all sorts of nice curve-based animation interpolation styles here, so it looks a lot smoother and natural, the movement I'm playing around here, though because I'm setting my values to completely meaningless sort of ranges right now, the output is meaningless as well, but it's a demonstration. And I can also zoom here, see the full timeline, goes to 7 minutes. Zoom in very closely if I really want to get fine control of the time, and the sound is also seekable thanks to HTML5. So that's how really my workflow for WebGL goes right now. But it has some flaws as well. You can't really dump the timeline sort of keyframe values. When I'm done, I'll just have to open a JavaScript export window and just go line by line and export everything by hand. Not really nice, but once again, motivation ran out, and I didn't want to code something that dumps into a file, and it's a never-ending problem, really. And shader code still requires reloading of the page, but yeah, pressing F5, not that bad. And usually I just write the shaders beforehand, add parameters, so I can animate them on the timeline, and then I just don't touch the code at all, because I usually don't have to. It's already doing what I want to, and I just have to parameterize it. HTML5 audio support is still rather flaky across browsers. I can't get the same sort of effects and FFT stuff out of Firefox that I can get in Chrome, and vice versa. There's a lot of differences in the way the audio is implemented. Requires some time to mature the support for those stuff. No cross-browser FFT support, which is a big minus. I really like doing beat syncing and audio analysis with FFT, so I'm missing that here because it only really works well in Firefox. And WebGL is still not available for mobile browsers or Internet Explorer, because the first sort of idea was, okay, I'm starting to make a demo, so I'll make it resolution independent, device orientation independent, and make it run on all Androids whenever they come out with their WebGL support. Yeah, still waiting. It's probably takes some time to people actually getting around implementing on mobile browsers. Safari already has it on their version control system for the desktop version of Safari on OS X, but no word on really whether mobile Safari will support WebGL at any given point. Some rumors, but not any sort of concrete information about it. But still, WebGL is a V3 standard, and pretty much all major browsers except IE have planned support for it in their development roadmap, so it's coming. A lot of people think it's the way to do GPU stuff on browsers. And the most important for me is that no plugins are required anymore for GPU accelerated content. So beforehand, the only way to really access the power of the GPU was to use Silverlight or Flash or ActiveX or all those sort of vendor-dependent plugins or scripting interfaces or whatever. Just not for me. I'll never touch those if I'm doing something that I actually reuse in the future as well. And no third-party components required. Only new enough browser, and that's it. And a GPU. And what did I learn from starting from pixels and then going to fragments and GPU code was that pixel shaders in particular are pretty similar to frame buffers in many ways, because I just setting fragments instead of pixels, which are just resolution independent fragments of the image I'm processing at any given point. Usually the way I do it is I'm just rendering into a single quad on the screen that's the size of the screen and have a texture that's large enough resolution for whatever I'm rendering, and then I just go around happily setting fragments as I would do on a frame buffer, really. The main difference with fragment shader and a frame buffer is that many fragments are calculated concurrently because the shader program is run in parallel on the GPU, so many fragments are being calculated at the same time, and I can't really control that. The GPU does it internally, and I'm just setting by coordinates of fragment coordinates of controlling what I want this fragment to be when you are done with it. And as I've sort of learned when I'm been programming OpenGL is that I tend to avoid calculating complex geometries, a lot of polygons on the screen and models and all that stuff. I don't think it's just necessary for me. I can do my stuff on a single quad and fragment shader. It's been enough for now. And what I really want from the GPU is complex blending and processing, so I can have a lot of layers of very complex pixel style effects blended together to get a very, very, very complex rendering result out of it. And usually what I'm doing is simply impossible to do on a frame buffer and have it quick enough. Or maybe I'm not that good of a coder. Maybe somebody can, but I can't. So I'm just doing it on OpenGL then, because it's fast enough for me. And to end my presentation is a demo I did, the larger project I did with Daruma GL called MKULTRA. Also on the internet, so just have to go here and start it up from here.
The legend is always the same. Nine immortal men live on top of the mountain. 40,000 years old.
So, just to sum everything up is that probably what I'm doing next is trying to learn from the mistakes and the things I found about computers in general with making spliff, and learning whatever I did on the browser will greatly influence whatever I'm doing next, and I really don't know, but hopefully it will be even more versatile and more easy to use and even better and better and better and whatever. You can always sort of tweak everything to a sort of level of madness that you start running into the actual problem of spending too much time developing the tools and less time developing the actual visuals and doing something that's actually completed in time and getting something done in anyway. So it's always sort of a fine balance with those two, because I tend to get really interested in some technology and then just spend way too much time tinkering on it and tweaking it and making it better and redesigning it from the start. And yeah, hopefully I will find some sort of compromise for it. Yeah, thanks for listening, and I hope you enjoy assembly.